Today is the 5th of September 2023, and I'd like to talk to you about scatter diagrams. Thank you to everyone who has been watching our videos, and please, if you could consider subscribing, sharing, liking and following us, I would really appreciate that. I normally write in the comment section, please follow my notes/script. Okay, so for instance, this is minus 3v. So if all this is 45, so if you hear 5, it's not 5, it's 45. Okay, whatever I'm pointing on is what I'm trying to explain. This is minus, this is 3v. So for instance, if I say 45, okay, or 5, it should be 45. Okay, I'll really use your help on that. And then beware of scammers. Don't give your money to anyone online that you don't know. Okay, so if they come and say, we are collecting money for charity for an orphanage, and they send you a number or an account, please, it's not me. Don't fall for scammers. I'll recap. Last lesson, we were solving equations. So like find x, find p, find y. Okay, so I'll really do a quick recap on that, because we were looking at integers, positive and negative whole numbers, including 0. I wanted to put in some negative variables so that we can use it and see how easy it can be if you understand the principles. And I hope you've updated your flashcards as well. So here, find v. 8v minus 40 equals 45 minus 3v. So 8v, now this is minus 3v. So if we move it to the other side of the equation sign, it becomes plus 3v. Now we have plus 45 here and minus 40 here. So if we move minus 40 to this other side of the equal to sign, it becomes plus 40. So 8v plus 3v equals 11. 45 plus 40 equals 85. We haven't finished because it says find v. So now to have v, we divide both sides by 11. So if we divide 11v by 11, v is on its own now. Then we divide 85 by 11. We can't reduce it any further. So our answer is 85 over 11. And I said to you, if you're in a calculator page, you can leave your answer as a decimal or a mixed number. but I will just leave my answer as this, because if this is the first part of a question, it means at another time you might have to use V and substitute somewhere. Okay, so I'll rather leave my answer this way so that if I have to substitute and do something else with it, this will be a lot easier. And then it saves time as well. If they've not asked you to do something, don't do it, because you won't get extra marks for it. Now, as starter, a bag of crepes has 3 red crepes, 4 blue crepes, and 5 pink crepes. Okay, you pick one at random. What is the probability that it is a red or a blue? Okay, but we remember mutually exclusive events. That are events that cannot happen at the same time. So here, you can either pick red or a blue, and they're asking you what is the probability of picking a red or a blue. Now the total in the box is 12 crepes, because you have 3 red, 4 blue crepes, 5 pink crepes. Okay, so now if R equals red crepes and B equals blue crepes, then 3 red crepes, the probability of picking a red crepes is 3 out of 12, because you have 12 in the bag. Okay, you have 12 crepes in the bag, 3 red crepes, 4 blue crepes, and 5 pink crepes. Okay, the probability of picking a blue crepes, you have 4 blue crepes, so that will be 4 divided by 12. Okay, so the probability of picking a red or a blue crepes is 3 divided by 12 plus 4 divided by 12, which is 7 divided by 12. We can't reduce this any further, so we'll leave our answer as that. Today we want to look at scatter graphs or diagrams. Okay, now before today I've been speaking to you about data and meanings of some of the terms that we use. Okay, like primary data, secondary data, population, census, survey, group data. Okay, with scatter diagrams, it allows us to see if there is a relationship between 2 sets of data. So for instance, if you walk into the shop and you ask for their sale for a school shoe and maybe school uniform, assuming that shop sells both, okay, you can find out if people who come in are buying both school shoes and school uniform, or they're just buying one. Okay, or maybe just by looking at the receipts, okay, that they have on their computer. You can also see whether they are buying school shoes and school bags, or PE kits and PE bags. So it is a way of looking at two sets of data. Okay, so for instance, if you have a child, normally when you take them after birth, you have to take them to visit the health visitor. So assuming they weigh them and they take the length of that baby, you can see a relation. Okay, the health nurse draws a graph. So if something goes wrong and they are not expecting that weight, whether it is too large or too small, then they will be able to find out what is wrong before it gets out of hand. Okay, so now we have three types of correlation. So we have a positive correlation. Okay, so both set of data will increase. So for instance, what I just said, assuming you have the age of an infant and their weight, okay, so you expect it to go higher, especially when they are born. You expect it to go higher and higher and higher as the baby grows. In months, you expect the weight to increase. Okay, so this is two sets of data, and the correlation here is positive. It's a strong positive, because when you look at the data plotted, it's closer to the line. Okay, there is something called the line of best fit. Okay, so you try to draw your line such that it's when you measure the distances from the points you've plotted on both sides, they appear to be equal. So if you look at this line, you realize that it has a strong correlation. Okay, there is another type of a positive correlation, that it is going in the positive direction. Okay, and both data are increasing, but they are a bit far away from the line. Okay, because if I draw my line this way, okay, I leave all these points behind, and if I bring the line that way, okay, more of the points will be at the top. So I have to find a way of drawing it such that the data or the marks and the points I have plotted is in between. Okay, and you can see that this is in between, but they're a bit far away. So this is like a moderate correlation. Okay, so, and then we have the weak one as well, where they are very far apart, but you can see the trend that the this thing the line is going in this direction. Okay, in the positive direction. Okay, it's gradually increasing. So in the negative correlation, as you can see, this is a strong negative, but it starts, one is increasing and one is decreasing. Okay, so for instance, if you drive your car weekly, you have less petrol. So you might start the week with a full tank, but as you drive it around, you have less petrol. So that would be a negative correlation if you want to plot it. But on the other way around, the more you drive, the more it will cost you. Okay, so that would be a positive. So when you drive more, you pay more fuel. So both variables are going high and high and high. I hope I'm clear on that. Okay. Now this is a strong negative correlation. Look at it. The data is very close to the line, and you can see clearly that it's going downhill. Okay, so it's negative. You have a negative gradient. This is a positive gradient. Okay, now this is moderate. Okay, because the plots are around the line. So if we plot it this way, okay, we'll have more plots at the lower part of the line than the upper part. And if we plot the graph in that way there, okay, we'll have less. So we want to do it in the middle such that we have a baseline fit. So it appears this looks like a baseline fit. Okay, assuming we have more points around, then it becomes weaker. Okay, so it becomes like a negative correlation, a weak negative correlation. So we can see that the two sets of data, one is increasing and one is decreasing, but they are fairly spread apart. Okay, now when we look at this graph as well, okay, this has no correlation. Two sets of data, and we can't see it. We don't know whether it's going in the positive direction or the negative direction. All we know is we've plotted the graph. It's a scatter diagram, but it's all over the place. So for instance, a Gcse result has nothing to do with age. Okay, it is like if you did well in the exam paper, then you will get your grade. Okay, or a failed result or an A-level result has nothing to do with height or weight or shoe size. All we know is if you did well in the exam paper on the day, depending on the marking scheme and what has been marked, the results are there. So it hasn't, we can't see any correlation. Okay, now school uniform sales and school shoes sales. Okay, if we look at it, in summer there'll be a high uniform sale because September is coming and children are going to go back to school, and there'll be shoe sales. Okay, but in winter, so in summer it might have a positive correlation if we want to compare two sets of data, but in winter it might have a negative correlation because people have already bought their shoes in the beginning of the year and they might not buy it again till the next year, because they expect it to take at least a year for it to wear out. Okay, so they might not go back and buy another shoe unless it is winter and maybe the shoes hasn't got a good grip. But not most parents might not, because they've planned for that and they've got a school shoe that has that this thing, grip to take them through the winter and throughout the year. So in winter there might be a correlationship between the weather and the amount of coats sold. Okay, so there might be a positive correlation there because it's very cold. So people might who don't have coats might want to get coats. So there might be a lot of people who might end up buying coats. Okay, but in winter, most people are not going to buy coats. In summer, most people are not going to be buying coats. So there will be a negative correlation between the summer month sale in coats, okay, than the winter month sale. I hope I'm making some sense here. So for instance, ice cream in summer is very hot. So people might want ice cream to cool them down. Sunscreen, they don't want to have skin burn. So there'll be a lot of sale. So in summer, there'll be a positive correlation. Okay, so this is what I wanted to show you today. Tomorrow I'm going to discuss how we draw the line of best fit, and then we'll look at some examples, hopefully. Okay, this is a line of best fit. Okay, because you realize that if you look at the distance from the line to what is plotted, so if they give you a set of data, two set of data, and you plot them, you might have to decide what is your line of best fit. Okay, and use it to find the gradient if asked to. Okay, but you might have to judge that, and if it's accurate, it might not be the same, but you might have answers in a small range. Okay, if you draw it accurately. For instance, you can see that the line I've drawn here in my negative, a positive correlation graph. Look at the distance there. Okay, so you can check and see that it's exactly in the middle with the negative as well. Now this is a moderate positive. Okay, and you can see that there is equal amount of plots, fairly equal. So just by looking at the line, that is my line of best fit. Okay, so we'll talk about more of that tomorrow. Okay, or in our next lesson. So thank you very much for watching today's lesson, and I'll see you in the next.